Let's talk about some different data types in Mathematica. Here I've saved the variable y with the value of 5, and I can find out how that's being represented inside of Mathematica by using this function head. And that tells me that Mathematica, it's viewing this variable y, it's viewing it as an integer. And so what about for MyList? Well, you already know what data type this is. It's a list. What about for the entries inside of MyList? Well, let's go through them one at a time. And I'm going to make a table. And that table is going to contain each entry in MyList followed by its data type. So this is going to make a list of lists. And an entry, that's just a variable name I chose. And so each of my inside lists, it's going to be of the form variable followed by data type of that variable. And using the second type of iterator, this is for every entry inside of MyList. And let's make it a little easier to look at by displaying it in table form. So 3 and -10, these are integers. X, notice how x is blue up in my original list, so it hasn't been saved yet with a value. X is just a symbol. Okay, unlike this y, which is an integer, if I were to clear y, okay, notice how it turned blue, and then I evaluate this head command again. Now y is also a symbol. So x, a symbol, 3.14, a real number, pi, a string. And that's not so obvious to me looking at this that it's a string, but if I go back to the original input, it's inside these double quotation marks, so that makes it clear that it's a string. Here, pi, I think I might have expected it to be considered a real, but you can see that it's being considered as a string, or not as a string, as a symbol. Being considered as a string would be bad. So pi, that's a symbol, but it does have a numeric value, and I can test that by evaluating this function numeric q on pi. And so this is supposed to return true or false. Is this numeric? Okay, true. Here, this green disk, this is a graphics object. Here, this picture of pi that I got using web image search in Mathematica, this is an image. And you can see that all of these head names, they all start with capital letters because these are all built-in things inside of Mathematica. So this here, it's the original list 6y hello. And I guess it's a little confusing because since evaluating this table, I've cleared y. So let me go back and reevaluate y equals 5. Okay, so now it makes a little more sense that 6y hello corresponds to 6.5 hello. Okay, and that corresponds to a list. That triple here corresponds to a list. And 4 divided by 5, that corresponds to a rational number. And so what if I want to just get the integers out of MyList? Well, here's one way. I can say cases of everything in MyList. I want all the, let's say z, since I already used x, even though I never defined it. Let's say all z such that z is an integer. Okay, and it takes out 3 and -10. 3 and -10 here. And you might have expected that this 6 and this y would still show up, but when I'm using this cases function, it doesn't go inside the inside lists. So it just says, is this whole entry, okay, this will be called z, is this z an integer? No, it's not an integer, even though it has integers inside of it. So that just counts as false. No, it's not an integer, so this doesn't get kept when we take the cases. But here's another way to do the exact same thing. I can say cases of MyList, and well, let me first show you, I don't need to name this variable. I could just say give me all the cases. And usually we write the variable name before the underscore, but I can also write something after the underscore. So I can say, give me all the, well, not quite everything, give me all the integers. That's what this is saying. Okay, or if I say cases mylist underscore string, okay, that gives me all the strings. Okay, it was just this one, pi. Or here, give me all the symbols. Or here, give me all the lists.